Assalamu alaikum people. This is the problem that I wanted to ask before getting into the next problem. And in this problem I have an analog clock showing us 5:30 o'clock. Now we have to find the exact time between 5:30 o'clock to 6 o'clock at which the angle between the hour hand and the minute hand is gonna be 90 degrees. So please pause the video and try it out on your own self. And if you found out what is expected, then also I would expect you to continue watching the video because you may learn something about physics out of it. And actually I'm going to make an attempt to explain a physical phenomenon through this example, which might be helpful for you in future. So the first thing that we are going to notice or to put into our consideration is the angular movement of the minute hand per second. And obviously in the second thing that we are going to consider, because we are considering a mechanical clock, so the things are going to be smooth, not tick 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 tick. So obviously there will be some little bit of movement in the hour hand per second. So let's see. So now the simplest thing that we can do, we will subtract both of them. The angular movement of the minute hand minus the angular movement of the hour hand, and we will get something like this. This is actually the relative movement of the minute hand with respect to the hour hand. And since it is already 5:30 o'clock, which means that the angle between both of them is 15 degrees, so the rest is 75 that it have to cover. So the time taken to cover with that relative movement is 75 divided by the relative movement of minute hand with respect to hour hand per second. So it's 9000 divided by 11. Isn't it looking a little bit more complicated than it should be? Well, then we will make it a little bit simpler by converting these seconds into minutes by dividing it by 60, and we will get something like 150 divided by 11, which can also be written as 13/7 by 11. Now if we add this with 30, we will get like 43/7 by 11. So it's 543/7 by 11 minutes at which the clock is going to show us the 90-degree angle between the hour hand and the minute hand. So you might be wondering, how is this example related to physics in any ways? Keeping in mind that the first thing we did was calculation of angular movement per second of minute hand and hour hand, which in terms of physics is known as angular velocity, that is the rate of change of angular position per second. Next, we calculated the relative movement between both of the hands by simply subtracting the former with the latter. It's just like two men running along a straight line in the same direction. So the relative velocity of man A with respect to man B is the difference of velocity of man A with the velocity of B. It looks just like motion in a straight line. The only difference is instead of displacement, we have angular displacement. And instead of velocity, we have angular velocity. And just like displacement along a straight line have units like meters and kilometers, we have units of angular displacement as degrees or radians. So obviously you might have already guessed that it also have an angular acceleration, which is the rate of change of angular displacement. So we can also apply the formulas for motion in one line in case of angular motion, or better to say rotational motion. The only difference that you will notice is instead of displacement we have angular displacement, instead of velocity we have angular velocity, and instead of acceleration we have angular acceleration. But there will be no angular time. Time is always time because it does not change according to the type of motion you are executing. It is kind of like a relative thing, So wait for the next one. Till then, bye bye. Assalamu alaikum.